For our college here at BYU, came up with a list of 13 competencies. Other researchers have come up with 8, and some with 10, and some with more. But there's a group of competencies that engineers should have if they're going to be successful in kind of doing global design or collaborative design. What are they? Well, here's some of them. Can appreciate other cultures. Okay, that's pretty obvious. Are able to communicate across cultures. If I were to say yes as an answer to a question that one of you would ask, what would my yes mean? It would mean that I would either do or that I agreed with what the question was, right? But in other cultures, when you hear the word yes, they're simply saying, I understand. They're not saying, I agree with, I will do it. They're saying, I just understood what you said. Knowing that about a design team member can help you kind of drill down and get to the point of understanding and communicating across this cultural barrier. So if you knew that you had somebody on your team that was from the United States and they said yes, you would expect that yes meant exactly what Americans believe that it does. If we were in an Asian culture, oftentimes, when they say yes, it simply means I understand what you're saying. Now, if they've been and lived long enough in the United States, they may know that if they're talking to an American and they answer yes, that means that they have committed to do something, right? So being able to communicate and know what people are saying and what you're saying to them is important. Are familiar with the history, government, and economic system of countries. Speak a second language at a conversational level. How many of you here at BYU speak a second language? Okay, if you look at the numbers of our ME population here at BYU, it's better than 75% of us speak a second language. If you go to foreign countries and you ask that same question, you'll see that a high percentage of them speak a second language, and usually the second language is English. Not always, but frequently it is. Okay? If you go outside of BYU to other colleges and you ask the question of predominantly just American students, not the visiting students and that, if you ask just American students, you're going to find out that the percentage of those that speak a second language conversationally is about 30–35%. Okay. So we have kind of a little bit of an advantage here at BYU. It just means that we look a lot like other countries and other cultures who have adopted a second language, and oftentimes the second language is English. Okay. Another competency is not just speak a second language, but be able to do it on the technical level. Okay. Now that's where some of the BYU students have a little bit of an awkward moment, is they know conversationally how to talk about religion and things like that as a second language, but sometimes in the technical area you struggle. Well, in the classes previous to this one, we have found that the BYU students are able to link up with their counterparts that speak the same language. So a student here at BYU that can speak Portuguese kind of conversationally gets hooked up with a USP student who speaks it natively, and that helps the BYU student pick up some of the technical vocabulary that is missing from their kind of competency. Okay, so This class, because of we try and link up languages as best we can, will help out. Are proficient working in or directing a team of ethnic or cultural diversity. Can effectively deal with the ethical issues arising from culture or national differences. So this is just the list. Understand cultural differences related to product design, manufacturing, and use. The green ones that I've highlighted are the ones that in this class we tend to try and focus on. Understand implications of cultural differences on how engineering tasks might be approached. So as you work in a team, I would expect you to say, well, this is kind of how we've been taught here at BYU. I would expect the other team members to say, well, this is kind of how we've been taught to do a design approach or a design method. And you don't immediately kind of pound your fist and say, we win. What you do is you negotiate on which approach to use. If they're totally conflicting, which generally they're not, then you have a real debate. But if they're just slight differences, you need to still sort out the differences. Okay? And so, by and large, what you are doing in this class is trying to figure out how to make this diverse team come together and look like a single design group working on one goal and one project. Have had a chance to practice engineering in the global context. And so you, small group of BYU students and the small group of students at the other campuses, you're going to be able to put on your resume at the end of this class, you're going to be able to say, I have practiced engineering in a global context. And that ought to be worth something as you interview and try and find a job when you leave BYU or one of the other schools. Because there are tons of companies out there that still today struggle with the global design process. And they're looking for engineers that have practiced, have done something that has allowed them to actually work across time zones, work across culture, work across some of these ethnocentric issues. So what is collaborative design? Well, if you've read in the textbook, this is straight out of the textbook, is an interactive process of real-time communication between members of a design team who are physically in different locations. A little further on, it said, fosters the ability to conceptually design a product in a distributed manner by involving a supply chain and other members who have experience to accomplish the design task. So this notion of we know it all, we can do it all, has gone. What we want to do is look across the world and say, where can we find the best skill set? Where can we find the best manufacturing, the best engineering talent? And if we can bring that together into a cohesive team, we can win against our competition. It's no longer we can find it all in Detroit. Another comment on real collaboration, more than just exchanging documents between designers on an on-time basis. Okay? 10 years ago, when they started doing kind of the collaborative thing, it was very common to try and chase the sun. They would work on a model for 8 hours in the United States. They would throw it forward to Asia. They would work on it for 8 hours. They would throw it forward to Europe. They'd work on it for 8 hours. They would throw it back to the United States. And hopefully 24 hours of work had productive work had gone into that modeling exercise. And so this notion of just, you know, I'm always just moving the model forward is really not collaborative design. Okay? It may be hopefully getting some efficiencies, but it's really not kind of bringing them together and working and trying to solve the problem together. The collaborative design requires that you have common goals. So you, the three of you here at BYU, your 3 remote students or team members, need to have the same identical set of goals. You need to say, this is what our goals are, and this is what's driving us towards our final project presentation. It should use each other's insights and talents. Done both synchronous and asynchronously. So from our very first lecture, are we going to regularly have the students from Taiwan, the students from Pony, the students from China, are we going to regularly have them here in our class, dialed in? Are they going to regularly be in our lab sessions? Probably not, because it's either very early in the morning or very late at night, and it's difficult for them, as you could imagine, for them to just say, well, I'm going to stay up till 2 o'clock in the morning to listen to Dr. Jensen talk, okay? It wouldn't be what would keep you up at night, right? So because of that, we are recording these lectures. We're putting them out on YouTube. They will listen to them. They're committed to going in and watching the material and looking at the material the next morning. What it means to you that work with these teams is you can't demand that an ideal time for you and a horrible time for them is when you're going to plan your group meetings. It's just not fair. If you do that one week, you have to then accommodate them by allowing them a good time and you an ugly time for staying up. There needs to be some kind of give and take to make this thing come together. And so one of the things that you're going to have to think about is, when are my team members connected in synchronously? When are they connected asynchronously? And can we find a way to make this work? That is exactly how GM does business. It's exactly how Boeing or Airbus or any of the other US companies, Embraer, I'm sure does the exact same thing. If you work for Renault, I'm sure they would do the same exact thing. They find a sweet spot for the team members that they have to reach out to. And it may inconvenience them a little bit, maybe a call at 8 o'clock at night here in the US, but it's a decent time, not a perfect time, but it's a decent time for the remote people that they're connecting up with. And so this element alone, if that's all you were to take out of chapter 19 and go forward with it this semester and think about where is the sweet spot for working with these remote students and how can I make them friends and associates even though they are at a distance.